Okay, let's find the gradient of this curve at x equals a using the limit process. So if you remember the definition of derivative, which is basically stemming from just the slope, says the limit as h approaches 0 of f of x plus h, which is y2 minus y1 all over x2 minus x1, and the x's cancel, and we're left with just h. Okay, so that's the definition of derivative, which is basically the slope for 2 points that are infinitely close together on the same curve. So let's go ahead and substitute in a. We want to know at x equals a. So the limit h approaches 0 of f of a, which is going to be f of a plus, well, let's just do it this way, a plus h minus f of a all over h. Just take another step, which means the limit as h approaches 0 of, substitute in a plus h, we're going to get a plus h cubed minus 2 a plus h minus f of a, which is just substituted in a. Make sure you have your parentheses because we have two terms. A cubed minus 2a all over h. Okay, let's start expanding. So with this term here, we're going to get a cubed minus 3a squared h, plus 3a squared h plus 3 a h squared plus 1 h cubed minus 2a minus 2h minus a cubed plus 2a. Okay, we're going to get some things that cancel. Cancel, 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 and cancel. Oh, and don't forget our divide h. And we still have a limit. We still have a limit until we can substitute in 0. Right now we can't substitute in 0 because we're dividing by h. But as soon as we can get rid of this h, then we can substitute in 0, and we'll find our slope that we're looking for. Okay, so let's rewrite, combine some terms if we can. 3ah squared, 3ah squared plus 3ah squared plus h cubed minus 2h. I'll divide h. Okay, every single term in the numerator has an h. So the limit as h approaches 0, take out an h, we're going to get 3a squared plus 3ah plus h squared minus 2 all over h. Now we can cancel. Gone and gone. Almost done now. We've gotten rid of h, which means we're looking at the limit as h approaches 0 of 3a squared plus 3ah plus h squared minus 2. Okay, if I substitute in 0, I'm left with, I don't substitute in 0 here, it's just the a's, no h's, so 3a squared. That's gone, minus 2. Here's our slope. So at any value a, the slope on this curve is 3a squared minus 2, which means if I had like a equals 3, I can plug in 3, and I'll get 3 times 9 minus 2, 27 minus 2 is 25, which means the slope at 3 of that function is 25, which is really steep. Function's going up very steeply at a equals 3 or x equals 3. But yeah, so that's how you do this problem. Hopefully that helps.